Welcome back to Networking Basics as we end up talking about more intense networking environments. And we're going to be looking at the larger environments that are out there that you might end up working in or might be involved in managing and in servicing. And that is data centers and SANs, which are storage area networks, and we'll look at servers and workstations and of course individual hosts. Enterprise level networking is also another subject area here. We'll look at different types of networks in these environments and the internet, intranet, and extranet environments that are available, as well as WiMAX and Wi-Fi. Networking in these larger, more intense environments is generally just like administering a land, except that it's just bigger. It's larger and there's just more of it. It can be time consuming and it can be a daunting task without delegating and assigning different tasks to appropriate personnel who can handle them. Sometimes it is also very strategic to divide the regular IT administrative tasks like servicing, user, setting up accounts and deleting accounts and group policy from the more IT security related tasks like auditing and intrusion detection, as well as managing routers and switchers and access control lists. Imagine for a moment just the management of company email for thousands of users in a company, say Price Waterhouse Coopers, that has many locations geographically as well as many employees. The, um, the amount of email that a company receives and delivers every day is huge, and we have to have uh, a dedicated team just to handle the volumes of concerns that can come in daily because not only of email from customers, but also email that has to do with different departments within a company and their communication with each other. So again, clients are not happy when they do not receive a professional and courteous response in a timely manner. So each one of these emails are very, very important. Data center management is clearly a critical responsibility for many companies. And also, we need to realize that the continuing expansion and development of both WiMAX and Wi-Fi as LAN man networks and virtual LANs, etc., and the subsequent integration of now very prevalent virtualization technologies has fueled this unparalleled growth in administrative capabilities and responsibilities. Data centers and SANs is the first major area here. And a data center is a facility that is used to house computer systems and associated components such as telecommunications and storage systems. It generally will include redundant or backup power supplies, redundant data communications, lots of ways to make connections, and environmental controls such as things for air conditioning and fire suppression and humidity control and other security devices. The SANs portion or storage area networks are capable of hosting large segments of data for fast compression and retrieval services. And this is a very specialized area as well. As you can imagine, a bank or a financing company of some sort, perhaps a broker dealer like a Raymond James, for example, in Tampa, St. Pete, Florida, would need to have a data center with huge email connectivity and response and SANs networks that would host and hold tremendous amounts of information at one time. The typical network, of course, has users who are sitting at workstations running applications like word processing and spreadsheets. The workstation is known as a client, which is just a basic computer running a client operating system, such as Windows XP, maybe Linux, Vista, Windows 7, whatever. These users typically store their files, though, on a client server so that they can share the files with others across the network. The server is a special computer that contains more disk space and memory than is actually found on the client workstation. Sometimes you have servers that are just dedicated for application purposes, and they're called application servers. The server has special software that is installed that allows it to function as a server too. And this means that you can also have a server that's in the role of, say, a file and print server, or maybe strictly an email server, or maybe it's a server that's actually going to support domain controller requirements under Active Directory. So you can have a web server too that's going to provide web pages to clients and so forth. So the term host will refer to any computer or device that is connected to a network and sends or receives information on that network. A host can be a server, a workstation, a printer with its own network card, or a device such as a router. But we can summarize by saying that any system or device, though, that is connected to the network is known as a host. Now, at enterprise level networking, we have enterprise level server services, or those that provide on a large scale to the entire network. These services primarily support the network completely itself. They are services that support other servers and keep the corporation-wide information synchronized on all areas of the network. We have things involved here that we've mentioned before, like DHCP, which is an application layer protocol in the TCP/IP suite, and this protocol is responsible to dynamically assign IP addresses. So it's a way to keep the administrator from having to deal with static addressing, which would be a nightmare in an enterprise level networking situation. There is also WINS. It's an older form of NetBIOS name service, and it's called WINS. It's Windows Internet Name Service. It's a name server, and it serves the NetBIOS computer names. You don't see much of that around anymore, but that's an item that you might come across. We've mentioned already the domain name system, the Internet Protocol for the assignment of domain names through registration and root servers, and a domain name is www.yahoo.com as an example. There are network logon services too. This is a major service. It's responsible for communication between systems in response to a logon request, and can include a domain synchronization request and a request to promote a backup domain controller to a PDC, a primary domain controller. Now this is under Windows NT strictly speaking, but under Active Directory we don't really have PDCs and BDCs. We just have DCs, domain controllers. For example, we'll have a domain controller in the forest root domain, and on that domain controller will be the global catalog, and along with that will be the configuration setup for the forest, as well as the schema master for the forest as well. So there's a lot going on that's similar to NT 4.0 It's just been made more extensive and more of an object-oriented style network using Active Directory. Active Directory, which Windows created using LDAP, Lightweight Directory Access Protocol, as a model, along with X.500 as another protocol that was found useful in developing this directory service. So that's the application of a network logon service, and having to keep track of people who have passwords and then what they have privileges and rights to in terms of the groups they belong to and the assets that they can have access to on the network. There's centralized services. It's a service which is provided to more than one customer, and usually all of them, to ensure a fast, efficient, smooth, and secure computing experience. There's replication and backup and point-to-point tunneling protocol, which is a method for implementing virtual private networks. PPTP uses a control channel over TCP and a GRE tunnel operating to encapsulate point-to-point packets. Routing and switching is also a very important part of networking. It's the process of selecting paths in a network along which to send the network traffic. Routing is performed for many kinds of networks, including the telephone network, which is basically a circuit switching network, electronic data networks, which is what we think of as the internet, and then transportation networks. Switching usually occurs after packets have been routed and are in need of distribution across enterprise networks. There are all kinds of networks out there, and you will find that we've discussed many of them already. The peer-to-peer network has no dedicated servers. Instead, it's just a number of workstations that are connected together for the purpose of sharing information or devices. When there is no dedicated server or workstation, all of them are considered equal. They're peers to each other. Any one of them can participate as the client or act as the server. Finally, we have the server-based networks, which is what you're going to find out is more prevalent. The big disadvantage of peer-to-peer networking is that you can't do your day-to-day administration in a single place. When you have a server-based network, then you can. With peer-to-peer networking, user accounts typically are created on all the systems, and data files are stored throughout all the systems. This leads to a more complicated environment and makes your job harder as a network administrator. We have file and print servers, which will control and share printers and files among clients on the network. File and print servers were the original reason to have a network. A large number of users needed access to the same files, and so the files were placed on a server, and all the clients were connected to that server when they needed to work with these files. File servers often have a lot of similar characteristics: large amounts of memory, fast hard disks. We have fast I/O buses, multiple CPUs to process information with, fast network adapters, high capacity tape drives to back up information with, and redundant power supplies when the power goes down. And they often have hot swappable hard drives and power supplies, which is very good to have in some circumstances where you might have frequent power outages as well as frequent need to back up information. I mentioned your application servers. These are the servers that run some form of special program on a server. I mentioned email, and I mentioned Microsoft SQL Server. which is a database server, a very special kind of program for managing and creating databases. But you can have other application servers that maybe have other programs on them, like an Oracle database program, Oracle 11G, for example. I think it's up to 12N now, Oracle 12N. There's Microsoft Exchange Server, which is their email version of a server. IBM Lotus Domino is another example. There could also be proprietary software systems that need to be on a dedicated server, given the type of business that's operating there or something to do with the government. There's web servers, and there are directory servers as well. And web servers are the ones that run the HTTP protocol and are designed to publish information on the internet or in a corporate intranet. Directory servers will hold the list of user accounts that are allowed to log on to the network, like I mentioned with Active Directory. Finally, you have the internet, where you can have access to intranets and extranets. You can expose information to the world, of course, across the internet, but maybe you want to just expose information to a certain group of people, and that way you have a company's intranet. The information on the company's intranet would not be accessible to persons on the internet because it's not for public use. It's used for, say, companies' employees only. And then there's also an extranet. From time to time, an application that has been built for the company's intranet and used by the internal employees will need to be extended to select business partners or customers so that they can have access to it. So you have something called an extranet, say business partners. And then in conclusion, we will mention WiMAX and Wi-Fi. WiMAX stands for Worldwide Interoperability for Microwave Access. Let me say that again. Worldwide Interoperability for Microwave Access. It's a wireless communication standard designed to provide 30 to 40 megabyte per second data rates. And it's been updated in 2011. It will continue to grow. It's not widely known right now. It can reach across the entire, you put a WiMAX tower, say, in the middle of the state of Florida, and it will probably reach from one side of Florida to the other. It has that much capacity to send a signal that can be picked up. And there's a lot going on here. There's a lot that can be said about it, but there's a lot that can't be said about it at this moment too. WiMAX offers data transfer rates that can be superior to conventional cable modem and DSL connections. However, the bandwidth that supports WiMAX must be shared among multiple users and thus will yield lower speeds in overall practice. So there's still some time to come and a lot of work to be done there. Wi-Fi, of course, is your popular technology that allows an electronic device to exchange data wirelessly using radio waves over a computer network. And this includes high-speed internet connections. The device that can use Wi-Fi, there's lots of them: personal computers, video game consoles, smartphones, tablets, digital audio players, and there's lots of hotspots where you can connect and create little networks using Wi-Fi. You have access points, that's what the hotspot is called, and it has a range of about 20 meters indoors and a greater range outdoors. Hotspot coverage can comprise an area as many square miles, so you can have university Wi-Fi is a good example of the use of Wi-Fi. You find it in small coffee shops. You also find it in other places such as McDonald's and so forth, where there's free Wi-Fi. So thank you very much for listening to the lectures on networking basics. I hope they've been fruitful and helpful to you, and they've helped the reading material to be a little more clearer. If you have any questions or concerns at all, don't hesitate to contact me. I'll be glad to correspond with you and help to clear up anything that might be on your mind. Well, thanks for listening.